But one of the things we haven't done yet, and we've even actually encountered some situations where we were writing code and there were errors occurring, but we really haven't talked about what do you do to handle errors that occur in your code. So in order to write an elegant solution to a problem, it is nice to be able to do error handling. Can you write code and solve problems without error handling? Yes, but it's really much more elegant and nicer experience for a user if you have good error handling. So we just want to talk a bit about how do you do that with your code. So if we hop to the slides here, you know, even the best laid plans can go wrong. You know, you go off, you create the shopping list, and then you get to the grocery store and realize you left your shopping list at home. Oh, I've never done that one. You know, sometimes I'm like, I know, I'll be smart, I'll put the list on my phone. Oh, and I leave my phone at home. You go out and you go out to buy a pair of shoes. You spend all that time trying on different running shoes, and then they discover they don't have it in your size. Just after you find the perfect pair.
My habit is, because I'll often run here before work, so I'll bring my work clothes as well, and I frequently forget my work shoes.
So you end up spending the day in the runners.
In my running shoes, yeah, exactly.
Related story, just a brief side, I'll get right back to the code. But I did one time, I used to travel a lot for work. I used to teach a lot of programming courses, and I would travel and I would pack the dress shoes for the work. And I had a really grungy pair of running shoes, and this is when I wore a full suit.
Okay.
With the skirt and the blazer, and I got to the training center and realized I had no dress shoes. So actually, no, I had packed dress shoes, but I packed one black and one blue, and they were both for the left foot. So I ended up teaching the entire course wearing a nice, beautiful business suit and a really grungy pair of running shoes.
I love every bit of that.
He said
funny.
The best laid plans do go wrong. I was trying not to wake up my husband when I was packing, so I grabbed two shoes, and apparently both left foot.
Yep.
You decide you need to call somebody, and you discover your cell phone battery is dead. You know, no matter what we plan for, things will go wrong, and that's going to be true when we're writing code as well. So things will go wrong when we're writing programs as well. So some of the scenarios you might have, you're writing code that's going to read a file, the file's not there. I have run into that one so many times. I used to write programs that would move file from one location to another.
Exactly.
And you know, it would read a file from one location, move it over, and load it into a database, a very common sort of scenario.
Yep.
You know, somebody sends me a file, I take it and I put it in my database.
Exactly. And you know, those are the types of things that you don't have control over.
Yeah.
That, you know, when I'm writing the program, if I have a mistake in my code, you know, that's me. But if I'm trying to read from a file, there's no guarantee that that file is going to be there tomorrow.
Yeah.
I have no idea. Yeah, exactly.
So yeah, so we often run into that scenario, so we need to be able to sort of handle that sort of error. You might have a situation where you ask a user to enter a date, and you tell them, hey, enter it as day, month, year, but they enter it as year, month, day. So, or they specify a date like the 30th of February. You go, wait a second, that's not going to work. So you have to be able to handle those situations in code. Or you are doing math in your program, and you hit the common programming error, the divide by zero. That one comes up quite common.
Absolutely.
So there's different types of errors you can actually run into when you're writing your code. First of all, there are syntax errors. And I think I'm going to go out on a limb and guess that everybody out there who's been practicing has had a syntax error. I know we've had several in doing our examples. Christopher's like, oh, I forgot the colon. Susan, you've got the parentheses around the print statement. These are great examples of syntax errors. Now, the wonderful thing about working inside a tool like Visual Studio is Visual Studio will highlight your syntax errors with that little red squiggly line. And you know what I love about that? It's the same thing you see with spell check in Word. We're actually used to the red squiggly meaning, go look here, you have a mistake here.
You have a problem here.
It's too bad they don't give you the autocorrect like they do for spell check.
Yeah,
That'd be nice. Maybe that's coming later. From IntelliSense, we could have a spell check autocorrect for our code. But no, when you see a red squiggly in your code, that's a hint that you have a typo somewhere. So if you actually look at this example here on the screen, you can actually see hello world, and what I've done is I've forgotten one of my quotes. So I forgot to put my opening quote, if I show here, I forgot to put an opening quote right here, so I get this squiggly line. I'll give you a little tip too, and I don't know if you've noticed this, Christopher, but sometimes where the squiggly line appears isn't exactly where the error is.
Exactly, but the way that I use it is basically is the end point. So I'll start there and work my way backwards.
That's right. So if you see a squiggly line, that means on that line or somewhere before that line, you have a typing mistake. It could be 2 lines before that you forgot to close a quote or close a parentheses.
Exactly.
So where you see the squiggly means somewhere there or somewhere before that you've got a syntax.
Yeah, that's basically, because Visual Studio and Python in turn are relatively forgiving. They're going to try and work with you. It's just finally reached a point where it finally just threw up its hand and said, I have no idea what you're trying to do here.
Yeah, when I got to here, I got confused. So somewhere back there, somewhere before this, there was a mistake. Sometimes the squiggle's right where the mistake is, but it does at least it's before that line.
Yep.
Yeah, which is helpful.
Getting a lot of Q&A of people saying, yeah, I've been doing this for 30 years and, still get lots of errors.
You know what? I said, you are not I don't think you're really a coder until you've made lots of errors. And the more mistakes you make, the better you're going to get at finding mistakes.
Yep.
And that's why I'm really good at finding mistakes in my code. Now, sometimes there'll be typing mistakes you make that aren't actually detected. You won't see a red squiggly. If you type in print hello world, which is incorrect because I would have to the IN there. So if that IN, I accidentally mistyped. But there's no red squiggly that appears if you type that into Visual Studio.
Exactly.
Instead, what happens is when you run the program, Visual Studio goes off and tries to execute this Python code. The interpreter goes and says, I can't find a function called print.
Yep.
And at that point, it then throws an error and says, excuse me, there is no function with the name print that I have in this code.
We actually saw this in the last module, that when I had defined the function down below and then put the code up top, that when I went ahead to try and run it, Visual Studio didn't give me any red squigglies. In fact, Visual Studio was even nice enough to give me a bit of IntelliSense. And then when I ran it, that's when it said, oh, wait a minute, you've got a problem here.
That's right. So these types of errors, you'll get error messages at runtime. Again, this doesn't mean you're a bad coder. It just means welcome to programming.
Exactly.
Look at the error message. It does often give you a really good hint. And actually, one of the cool things about Visual Studio and Python is it actually gives you an arrow showing you the line of code which actually generated the error message to try and give you a hint. And again, that means the error message is there or before.
Yep.
Not necessarily exactly where it's pointing, but there before is where the error occurred.
Exactly.
And said, but do check the error message. Sometimes there are options to literally links right there to search for help on that error message. If you're really stuck, go to Bing, type in the exact error message, name print is not defined, copy that into Bing, and type in the word Python so it knows it's a Python error message that you got.
Yep.
And you may well find somebody who's post Stack Overflow, I'm getting this error message. Why am I getting this error message? And some awesome developer out there has come and said, well, you're getting that because, and boom, you've just solved your problem.
That's it.
Yeah. So the other thing you'll run into is logic errors. These are the nasty ones, I will be honest, because the problem is the code runs just fine. You don't get any error messages, but for some reason, you're not actually getting the output you expected.
My forehead is a little flatter because of those. Just thud, thud,
These
thud.
are the toughest ones to find because sometimes you don't even know they're there. We looked at a couple of examples of these yesterday. We talked about if you have a salary of $5,000 and a bonus of $500, and we calculate your paycheck, and we get back a result of $5,500,000. Because
I like that paycheck. I'm just saying.
And the problem was because we put quotes around our numbers, they were treated as strings. So the plus symbol, when you use a plus symbol to take this string plus this string, it concatenates the two strings together. If you take a number plus a number, it adds the numbers together. So we end up with a total of $5,500,000.
Again, if somebody who's writing the HR app for whatever company it is that I'm working for at any given time wants to make a mistake like that and give me $5 million all of a sudden,
you're in?
I am all for it. Sold.
We also talked another example yesterday. We were seeing the challenges of an if statement.
Yeah.
I want to write code that says if somebody is a gold card member and they're from the U.S. or Canada, I want to give them free benefits. And then you write the code and you say, if status equals gold card and country equals US or country equals Canada, give free benefits. And then you suddenly go, wait a second, I've got somebody here from Canada. Why is everybody from Canada getting free benefits? That shouldn't be happening. And then you realize it's because the and was executed before the or. So everybody who is from the US that has a gold card gets the benefits. The US people who don't have a gold card didn't get the benefits because they weren't U.S. and gold card. But then it said, or from Canada. So everybody from Canada got the free benefits. You're like, no, 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 no. I want only the people who are gold card and are from U.S. or Canada. So just because I missed a set of parentheses in my combine and or statement, again, runtime error. Suddenly I accidentally gave free benefits to every single Canadian. Oh, I like that mistake.
Yeah, there you go.
Hey, if you don't mind making that mistake for any hotel chain or airline I
Should
fly
we just
with,
start requesting
that would be
mistakes
great.
we'd like people to make?
Yes, I think this is a good plan. Yes, I like that. So it's important that we have a way of handling errors. So said the logic errors, they're going to happen. How are you going to find those? Testing.
Yes.
You have to go through, test your code. The fact that it runs without an error doesn't mean it's working. So you have to test your code. You have to try different inputs. Make sure what comes out is what you expect based on what you enter. With ands and ors, try different combinations. Greater than, less than. Try smaller values, larger values, equal to. Try to break it, hack it. You know, it's really important to test.
Yes.
Now, the other thing that happens is you may have written your code absolutely correctly, and yet, and it's run and you've tested it a half dozen times and everything works. You've got this wonderful code that opens a file, reads all the contents of the file, displays it correctly, and then one day it crashes. Your user goes, the code doesn't work. And that's the day you go, oh wait, someone deleted the file. That's a different type of situation. Now you've got a runtime error that is only occurring occasionally when there's a specific situation. You've written your code correctly. You write a calculator program, and a user tries to do division and enters 0. So your code is now trying to divide by 0. Well, you know what? Calculators generally don't like dividing by 0. Your program tries to read a file, and the file's not there one day. Your program's trying to perform a date calculation, and a user enters the wrong format or says 30th of February, or asks for the 15th month because they weren't paying attention to the date format.
Yep.
So when you have the code just crash and spew error messages all over the screen, that's a very poor experience for the person using it. And even if you're writing functions that you're going to use, it's really nice if a function handles errors in a graceful way as well. So what we're going to look at in this module is how can we add code to trap errors gracefully so they don't just crash, but we can control what happens if something predictable as an error occurs. Because there are some scenarios where we just know they're going to be trouble. Things like reading from a file. That's the kind of thing where I can almost predict one day the file won't be there.
Yeah, absolutely. Yeah. Or you don't have permissions, or it's corrupt, or yeah.
Opening a file, that's one of those ones, you know what, always add error handling.
Yeah, exactly.
Standard.
Yeah, and really actually to take that one step further, basically the moment that you leave your application and try to contact something else, always add error handling. So, you know, to get a little bit more advanced, if you were going to try to call a web service, if you were going to try and connect to a database, anytime that you're leaving...
Anytime you're talking to the outside world.
Exactly, yeah. If you're going to open up the front door and go outside, make sure that you've got error handling.
Yeah, because you're depending on someone else now.
Yeah, exactly.
And I'd love to say we can trust others, but there you can't always rely on everybody else. So anytime you're calling someone else's code or someone else's database or someone else's file, yeah, you want error handling because one day they may not be there for you. So what I've got here on the screen, this is a very simple program. I wanted to have a nice, easy example we could all follow to start with. I've written a calculator program, and a user enters 2 numbers. This is a very rudimentary calculator. It can only divide. So, so maybe it's a divider program.
It's a divider calculator.
Yeah. So the users enter a number, 2 numbers. So we have just our basic, they input the first number, they input the second number. I convert those to numeric values because input returns what data type, Christopher?
Wait, I know this. String.
String, correct. So I convert them to numeric data types so that I can do math with them. Then I calculate a result, which is the first number divided by the second number. If I execute this code, it's going to work. Unless, right, I test it, it works, 6 divided by 2, 3.0, everything's looking great. Until, you know, we start messing with it. So let's get this up and running, because then we can actually mess around with it and see what it does. I'm going to need a new project. All right, let's create module 14. We are on 14, error handling. Trying to use good names so that if those of you who are looking for the examples later. So we're going to have first number equals input, enter a number, and I'm just going to be trying a little lazy here, Control-C, Control-V, and that's going to be second number, input, enter another number, and then I am going to, and I'm actually going to change my code a little bit. Again, I'm trying to be super efficient here. I'm being lazy. I'm going to convert them to float when I get them back right away. So I am taking the number that is returned as a string and immediately converting it into a number.
Okay.
So then I can take a result equals first number divided by the second number. Just because I want to get to the error handling. You guys have seen this stuff before. Hopefully this all looks familiar now. And then I'm just going to print the result on the screen. Really simple.
Okay.
Okay, I run my code. Phew, I got it right. Okay, no typos. Phew. I type in 5, I divide by 2, and it comes back with 2.5. So
right.
I go, yay, I've done my code. I hand it into my boss and I walk away. And I tell them to go give it to the users, and one day a user comes along and types in a value of 10 and tries to divide by 0 and psh, poof, crash.
Sound effects and all.
Yes, the user won't have Visual Studio. They're not going to see a little box pop up with code saying 0 division error occurred or anything like this. They're probably just going to see error messages all over the screen.
Yep.
But now, the nice thing about us as coders is we do have Visual Studio. And what I love is, again, if we zoom in a little bit here, you can actually see the line of code. There's a line telling me which line of code caused the error. And I can see the exact error message that occurred, 0 division error. That's really useful. We're going to take a little note of that. That's useful information. And there's a description of the error. There was a float division by 0, which is actually a really good description because I had a floating number and I tried to divide it by 0, and that's causing the error. So do take a look at that information because that is really useful when you're trying to write your error handling. You're going to want to know that information. Okay, so I have a calculator program. I now have an error that's running.
Yep.
So there's our scenario. We have our division by 0.
Yep.
So which line of code generated the error message? Christopher?
1, 2, 3, 4, 5. Well, in this screen, error 5, line 5.
That's right. In this case here, it's the line where I'm actually doing the division that's caused the actual error. It's important to know which line of code generated the error because that's going to determine where you're adding the error handling code. You could just put error handling code and say, if an error occurs anywhere in the program, do the following. But in this case, you might get different errors at different places. So it's actually better to say, hey, if this line of code gets an error, it might be divide by 0. If I have a line of code that opens a file, well, I'm expecting errors because it tried to open the file. So I might want to handle different types of errors differently, depending where they occur and what types of errors they are. So it's generally better to try and put the error handling around the chunk of code you think could cause a problem.
Yep.
So what we're going to do is we're going to add something called a try except.
Actually, you know, it was funny. I was hoping to time it perfectly, and I missed by that much. Somebody had actually posted it into the chat window maybe about a minute and a half ago, saying, "Hey, is there a try-catch like C#?" So there you have it.
For those of you who have used C# and used try-catch, we have try except in Python. The only thing is, if you use C#, you're going to keep typing catch instead of except by accident.
Exactly.
The syntax is you use the word try, and your colon, and hopefully by now you're starting to get used to the indenting. So the code that might cause the error, you put inside the try. So here's the code which I think may generate the error. And what I do is I write an except. So I say try running this code. And the reason it's called except is because we often call errors exceptions.
Yep.
So if an exception occurs, then I want to go do this instead.
The way that I always like to analogize this is it would be like if I turned to Susan and I said, "Hey Susan, can you do me a favor? Can you run down to the store and get me a
coffee?
bag of chips? Yeah, get me a coffee. Yeah, go down and get me a coffee." And so I want to make sure that she also understands what to do if something goes wrong. But what I don't want to do is I don't want to say, "Okay, Susan, go get into your car." And then if something goes wrong with getting into the car, I want you to do this. All right, now I want you to start the car and I want you to drive down. And if while driving something, because just like it would be annoying for somebody to explain all of that to you, it's annoying trying to program. So what I really just want to do is I just want to say, "Hey Susan, go down to Starbucks, get me a coffee, hopefully a dark raw roast."
Yep.
Then, if something goes wrong, get me an iced tea instead. So you'll notice that what I did is I just gave her everything of, hey, this is what I want you to do, assuming success. And then if something goes wrong, do something else. You know, basically let me know. And so if we take another look at the code, that's exactly the way that the code is written. Is you'll notice
try to do this.
Yeah, try to do this. No error handling inside the try block. We're just assuming success. And if something goes wrong,
then we're going to say, so we're saying if an error occurs anywhere in this code, it will jump to the except and execute the whole code here. So the only time you're going to see that message, print, "I am sorry, something went wrong," is if an error occurs in the code you have in your try. So let me go add that to my code. So let's try that here and see it in action. And I'll actually, so we're going to say try to calculate a result. And, you know, assuming everything goes well, after we get a result, I want to print it. So I'm going to leave that print in there as well, in this case. And then I'm going to say, now, in the event there is an exception, I'm just going to print, I am sorry, something went.
And then as Susan is typing all this out, I just want to mention real quick, somebody asked in the chat window about the possibility of throwing your own exception.
You can absolutely do that.
Yeah, and you can do that. Yeah, there's a raise function that you can go ahead and call to raise a brand new exception. And that's something you might decide to throw into your functions and so forth. For right now, we're just kind of focused in on error handling. But just to answer the question, quite simply, yes, you can. It's the raise function.
Yeah,
Yep.
and you would use a raise function. For those of you who are sort of going, why would I want to make my own errors?
Yeah.
It would be when you have business rules.
Yeah.
So if you have certain business rules that if somebody's trying to deposit money to a bank account and they try to deposit minus $1,000.
Yep. That's a problem.
Then you say, wait a second, if I'm depositing minus $1,000, is that or even better, I'm withdrawing minus $1,000, but I'm giving myself $1,000?
Hey, I like that.
Neat trick. Again, errors I'd like to write into your code. So that's something where you might have a business rule that says when somebody tries to deposit money, it must be the value must be greater than 0. And if the value is greater than 0 or not greater than 0, you might actually want to throw your own error to say, yo, hey, somebody's trying to deposit a negative amount. This doesn't make sense.
Yep.
So you use the raise command to raise your own errors.
Yep. And somebody else asked, is there a methodology on what to do with an exception? And a lot of times when somebody says exception handling, they make it sound very grandiose, that you could detect what the problem is and magically fix it. And yeah,
if the file's not there, the file's not there.
Exactly. And sometimes maybe you could execute some code and pull from a database and recreate it or something like that. But those times are so extremely rare that really all that you're typically doing is you're just simply going to write out to a file maybe, print a friendly error message to the user, and that's really it. Now, exactly when to catch errors and so forth, that's a much bigger conversation. But to kind of simplify it, go with the core part of it. Typically, when you catch an exception, what you're going to be doing is just exiting gracefully and maybe logging it out to a file.
Yeah, giving a nice error message so people have an idea of it. It's not them.
Exactly.
If you can tell someone,
it's not you, it's me.
It's not you, it's me. Yeah. The one situation where sometimes you can fix it is if a user entered something in the wrong format.
Right. Yeah.
Sometimes you have the ability to say, hey, you need to give me the date as day, month, year.
Yep.
Please enter that again, and then you go back to the code. You might have a loop or something or a function that you call to say prompt them again for that date value. So that's the one scenario that's the most correctable in your code.
Yep.
So if your problem is a user entered something wrong, you could write code that says go let them try again, to try and enter it again. That's probably the one most correctable error handling scenario. But most of the time you're just going to exit and say, sorry, I can't do this because this happened.
Yep, exactly.
Yeah. All right, so what I have in this code, what we have, just zoom in a little bit there, is so we've accepted two numbers. We try and do our division, so we're trying to do our division. We assume everything goes well. If something does go wrong, if there's an exception, another word for error, then I'm going to print a message saying, sorry, something went wrong. And if I run the code and I enter 10 divided by 2, well, everything goes great.
Yay!
Yahoo! And if, on the other hand, I try 10 divided by 0, I hit the any key a little too quick there. Sorry about that. 0. And you can see the error message comes back and says, hey, I'm sorry, something went wrong.
Yep.
So it's actually kind of neat if you actually, if we put some, put a debugger on here and I run this again. So we ask somebody to enter the first number, right? And then the second, so I enter the number 10. And then it says, then I'm about to execute the line and get the second number. So I execute that line of code and I'm prompted to enter the second number. I enter 0. And now you can see it's ready to go into the try statement.
Yep.
So it tries to calculate the result. And when I hit the step into, it's not going to go to the print statement.
No, and this is very important.
Yeah, it's not going to the print statement because there's an error. It immediately jumps to the accept and prints out the error message. So when an error occurs inside your try, whatever line generates the error, it will immediately jump to the accept statement. It will not continue executing the code inside the try.
Yep.
All right. Now, the other thing is also important to recognize is the code inside the accept will only execute if there's an error.
Right.
If there's no error, the code that you put in the accept never runs.
Yeah, that if you remember back to when Susan ran that a couple seconds ago, when she did 10 and I think 2, it just simply printed out 5.0, exactly what we were expecting, and it didn't print out, sorry, something went wrong, because, well...
Nothing went wrong.
Exactly.
Exactly. So.
Simple logic.
Now, one of the things, though, is sometimes you might know something could go wrong, but you're not exactly sure what the error message is that's going wrong. So you might just want to say, tell the user something went wrong, but something a little more useful than, hey, something went wrong. And then the user's calling up support and going, what's the problem? I was running the code, and I got a message saying, I'm sorry, something went wrong. You do that, and your support team is going to laugh hysterically.
Yep.
Because the fact is, if you are the coder, who, like the support team is usually people who fix code. And if you go to me and say, hey, Susan, I got a message that says something went wrong, how do I know what went wrong, which program was running, what type of error message was it? Give me a hint as to what went wrong so I can try and fix it.
Yep.
So one of the neat things you can do is there is a variable, actually it's part of a module called cyst, and it has a function called exeinfo. Not very intuitive, but really useful. And if you ask for, this will contain the complete error message. And the complete error message is actually a massive list with all kinds of details about where the error occurred, all kinds of stuff. That you might actually take that information in a big program and write it to a file.
Yep.
So the support team could look at it later to get the full information. But you wouldn't want to show all of that to a user, or they would just sort of be overwhelmed by it.
Right.
So usually we just take the first part of that list, the first value in that list is the message, which is divide by 0 error, or could not locate file. Something that a user might actually understand or might have meaning if they call support and say, hey, I got a message saying divide by 0 error or could not locate file. That's something the support team may actually be able to act on and be able to fix. Or if a coder can actually do something with that and hopefully try and fix it, or find out, oh, wait, we forgot to copy the file over. So what I'm going to do now is I'm just going to go back to my code, and instead of displaying a really generic message, which isn't that helpful, I am sorry, something went wrong, I'm going to actually declare a variable called error, which returns system.out. And I just realized I'm going to need to import the sys module before I can do this, because I am accessing functionality of the sys module.
And while you're doing that real quick, somebody had asked, could you simply test to see if it was 0, and if it was, then prompt the user for a different number?
And that would be even better.
Yeah, and you absolutely could, and that would be, a concept called validation. But divide by 0 is just such a great little example to do with the demo. So that's kind of why we're going that direction.
But you know what? So. But you make a really good point. If you can stop the error from happening in the first place, that's even better.
Yep, absolutely.
Sometimes we'll write code that will look for a file before we try and read it. So we can actually say, I just looked for the file, it's not there. And we come back and say, that file could not be located.
Yep. And then one other question that was in there, which is worth highlighting, is somebody asked about finally.
Oh, yep.
And there is a finally as well. And finally, just kind of real quickly, this is a block of code that will always run. So if maybe you needed to close off the connection to the database, you need to do that if everything went correctly or if things failed. So you could do that inside of a finally as well.
Yeah. Yep. Maybe I'll try adding it in a finally a little later, just so you can sort of see how that works. And I'll run the code and you can see how it executes. So hopefully I got the syntax right. I'm just going to double check the syntax of exeinfo bracket. Yes, I think I got it right. And then I'm going to say, then I can just print the error message to the screen itself. So what I'm doing now is I'm just asking if an error does occur, then I'm just asking the system to tell me what the error message was. And now I can tell the user that message. So now when I enter 10 and I enter 0, I can actually see there's a class 0 division error. It said the user, this isn't going to be that meaningful for them, but if they're calling support and saying, hey, I had this problem, that's going to help the support team figure out why they're getting this error message in the code and hopefully fix the problem so the user can get their job done.
Yep.
And that's actually really important. And yeah, just to talk about the finally, because somebody was asking about it, because in C# we have this concept as well. Finally, print, I always like to do this, I will always run. So you can actually have a line of code that always executes, or multiple lines of code that always execute. So I'm going to go back to putting in I'm going to put the debugger in again.
Okay.
And when I specify a value of 10 and a value of 2, you can see I'm in the try statement. I go to calculate the results. You can see by the yellow arrow the next line that's going to execute. Then I go print the result because everything's going fine. And then watch how the yellow arrow is going to jump down to the finally. So over here, hang on, what's the shortcut key for that? That is F11. All right, so I can zoom in a little over here. All right, so I'm going to zoom in a little. And when I hit the F11 key, it jumps right away to the finally.
Yep.
So the finally, so if everything goes well and there's no error messages, then we go and we do the code in the try, then we execute the code in the finally.
Yep.
And the message is displayed on the screen. I get my result. I get the 5.0 and the message I will always run.
Exactly.
And if I have an error, so let's try exactly the same thing, but this time I'm going to enter 10 and 0, so I get a mistake.
Yep.
And once again, I am going to go to my code here. I'm going to zoom in a little. So I'm at the line with the yellow arrow is the next line that's going to be executed. It tries to calculate a result. Because there's an error, it's going to jump right away to the accept.
Yep.
It executes the logic in the accept, and then it goes to the finally.
Yep, so the finally always runs, which is a big difference between doing that and just simply putting the call at the end of the try block. Because remember that the moment that the exception is thrown, it stops going down in the try block. That one of my early C# trainers taught me this, is that you're basically going this way in code rather than this way. That you're now going up in code, that it's just bombing out of that try block, and then it's just going to go straight for the accept block here.
Yes, so that's particularly important. As you pointed out, Christopher, the things like if you connect to a database, you need to close your database connection, or if you're opening a file, you need to close the file. Regardless of you have an error processing the data in the file, you always want to close the file. So something like a closed file might go in a finally, or a closed database connection. Those are most common scenarios you would encounter.
Exactly.
Yeah. Other than that, for divide by 0, I probably wouldn't bother.
Exactly.
Bothering with finalies anyway. So cyst.exeinfo, useful way of accessing error messages, and we just saw the finally clause.
Exactly.
Now, if you know exactly which error is going to occur, it is possible to say, if that error happens, here's what I want to do. And that can be useful. So you can say, if I can't find the file, tell the user I couldn't find the file. If something else weird happens, like maybe permission problems or something, then I'm going to display a different error message.
Yep.
So the way you do that is after the word accept, you actually specify the name of the error. Now, how on earth do I know what the name of the error is always the big question.
That's a very good question.
Well, you remember on the previous slide, I showed you cyst.exe_info?
Yep.
Guess what that returns? The name of the error. So I actually will often use cyst.exeinfo as a programmer to find out the error. I don't often display it to the user. It's a trick I use to find out the error. And then I know the name of the error to trap.
Yep.
So that I can say, if that error occurs, this is the message I want to display. I'm going to tell them, hey, you're trying to divide by 0? The answer is infinity.
Yep. And beyond.
And beyond, exactly. So what I can do now is I can say accept 0 division error. I'm just going to double check on that. 0 division error. Yep, got that right. And then instead of doing this sort of generic error message, I'm going to display a whoops, didn't mean to do that. I'm going to print a message that says the answer is infinity. And think of how nice that is as a user experience. It's not appearing as an error at all. I'm saying, yeah, you want to divide by 0? I'll tell you the answer to dividing by 0. You try dividing 10 by 0. Whoops, I've still got the breakpoint. Get rid of that. We don't need to step through this code. Try this again. From beginning. 10 divided by 0? Sure. The answer is infinity.
Yep.
On the other hand, if you ask me, what is 10 divided by 2? Well, it's 5. So this makes it to the user, but it doesn't even appear as an error. And that's a really nice way to do things, if the user doesn't even see it that way. What you may want to do is, what I recommend when I'm doing error handling, is I try to handle as many specific errors as I think, the types of errors, I can predict certain errors. I might try to open a file and the file's not there. I try to do a division, I might end up dividing by 0. So if there's errors I can predict, I like to specify what to do for those specific errors.
Absolutely.
But there are errors I might never think of. So I also include a generic accept, and this basically will execute if any, so when my code is running, it will try and calculate the result. If it gets a divide by 0 error, it's going to jump to accept 0 division error.
Yep.
And it will execute this code and exit.
Yep.
If it gets a some other number, like some sort of data conversion error, or the number's too large to store inside a float variable or something like that, it's going to say, oh, I've got an exception. Jump to the accept. Is it a 0 division error? No. Is it something else? Yes.
Yeah.
And it will go in order. So it'll check, it'll go, is it this error? Okay, then I'm going to do this. Is it this error? No, I'll do this. Is it this error? No, I'll do this. And then you have the, if it's anything else, here's what I want you to do.
Yeah. And, one other thing to kind of highlight, Susan mentioned, focusing in on the errors that you're expecting. And it is also worth thinking about if you are expecting something might go wrong, maybe test for it. We talked earlier about, 0, and just check for it rather than doing the exception handling. The other thing that I would mention is, again, going back to the module that we had prior to this about doing functions, is that a lot of this or all of this could wind up inside of a function. So rather than having all of that code right there, instead we could just put together a function that does that behavior and just gives me the answer back. Yeah.
Yep. Exactly. It's a nice way of doing it.
Yeah.
So we've shown how to trap errors. We showed you the finally clause.
Yep.
The other thing that's good to be aware of is if you do put code after your try except as well, that code would also execute all the time.
Yep.
So if you have code that's not indented, right, because only the indented code is part of your except error handling, well, what's going to happen if I run this code is it's going to try to do this code. If everything goes well, it'll chug along, and then it's going to jump to the first line of code after my try statement. So it's almost the same as putting it in a finally.
Right.
There's really not a lot to choose between making a finally statement that does that and just putting it after your full try except. Except some people like the format of the finally.
Yeah, some people like the format, and the other big thing is, somebody asked earlier about raise. So, and I'm going to say this, and I'm going to try very hard not to get too advanced.
Actually, I'm going to, you know what? Give me 2 seconds, because I'm actually going to show, I'm going to kick someone out in a second of the code. So I'm going to show how do I not execute this line of code. Will that lead in?
Sure. Go for it.
Because I think I know where you're going. So let me show one more thing, and then I think I'll let you run with that.
Go for it.
Okay. So it said, so in this situation, with this code I have on the screen right now, you could put that print statement in a finally, or the way I have it on the screen, and it really isn't going to make a difference with the code I have on the screen. Would you agree with that one, Christopher? For the code I have here.
Right now, yeah.
Yeah, it really wouldn't matter for this exact code. It would not matter if I used a finally statement or I put the print message here. I'm always going to see the print message. This message always displays. Now, sometimes, though, when we're executing code, we do want to actually say, oh, wait, if that error occurs, don't keep going. Stop. So there is a function cyst.exit, which you can use to say, get out. Or you can also, some people ask about raising exceptions. If you raise an exception, that'll also cause it to go, get out.
And that was actually the point that I was about to make, was about raising the exception.
Yes. Yep. So if you either call sysexit, that's just a way of saying exit now. Or if you raise your own exception, which hasn't been handled, because if you raise an exception inside your except block, you haven't written code to handle the exception in the except block.
Right.
So that causes the code to go, I'm getting out. In that situation, this code, if you get the 0 division error, when it hits sysexit, it exits, and this line of code will never execute. Now, what if I had a finally, Christopher?
Finally is guaranteed to run.
Exactly. So that's what the difference is between finally and having this line of code.
Yeah, and actually a lot of people have asked that. So it's good to highlight that the finally is guaranteed to run. And it's perfect, and again, we've been keeping our demonstration simple because we're trying to focus in on the syntax, but if you needed to close a file or close a connection, that's where finally comes into play.
Yeah, even if you use something like sys.exit, the finally will always run.
That's it.
So that's the difference between this syntax we have on the slide versus putting that print statement into a finally. The other thing you could do, this is just I want to show an alternative way of handling an error or sort of exiting, not executing certain code if an error had been raised. The other thing we'll sometimes do is we'll create a boolean variable and we'll say try running this code, and if an error occurs we set a boolean variable to true. And if it doesn't occur, we set everything went well, then we set the flag to false. And then after we've done all our code, we say, well, if the error flag is true, then continue executing. So I mean, you can just write logic that basically says if an error occurred, do this. If an error didn't occur, do this. And I'm just using a
Sure.
boolean variable, setting it to true or false based on whether or not the error occurred. So this is just creative coding.
Yep.
Lots of different ways to tackle problems. If you look online, you'll find lots of other examples of different ways to handle exiting code as well. If you actually look at the code here, though, there's other code here that could cause an error. We have code here. We've been handling the error that can occur when you divide by 0. But Christopher, can you see anything else in this code that might actually crash at runtime?
Oh, yeah, if somebody entered in Bob, a few people had pointed that out. Yeah. Or Wibble.
Yes, exactly. If somebody enters, when I ask somebody to enter a number and then I convert it to a float, if they entered letters or something that's not a valid number, then when I try and convert that to a float, which is a number that has decimal places, that code would crash too. So you might need to try except around first and second number. And I actually might do this separately. I might have one try except around the data conversion that handles the, hey, you entered non-numbers. And then if they do that, I say, well, try again. Whereas the divide by 0, I would handle differently. So you might end up with 2 try excepts in the same code.
And not only that, but forgive me for kind of beating on this horse a little bit more, but again, you could put that into a function. So I could create a function that says get number. And inside of that, I've got that try catch, and I'm just going to keep looping until you give me a number. Once you finally give me a number, then I'll go ahead and I'll pass that back. So rather than having that try catch twice, we just put that off into a function and then call that function. Yeah.
It'd be a lot tidier, a lot easier to read.
Exactly.
When you start having multiple try catches in your code, it can get kind of clunky. So you're looking at functions initially going, I don't know if I'm ever going to bother with functions. This is the kind of thing where when you get used to it, you're going to discover it's going to be a lot tidier.
Yeah.
And easier to follow.
We need to remember to say try except rather than try catch.
Oh, yeah. I'm sorry you've been saying it.
Yeah.
Our apologies. Yes, we both have spent more time coding C# than Python. So,
exactly.
So there's some habits. By the way, the further you get into coding, the more languages you will find yourself learning and the more you will mix them all up. You don't make less typing mistakes the more you code. You make more because you start using the wrong syntax.
Look at the number of colons that we've missed on if statements and other blocks.
Exactly. All right. So as I said, we've got a lot of different situations that might raise errors in our code. You might be converting one data type to another. You might be opening a file, doing a mathematical calculation, trying to access a value in a list if it doesn't exist. All of these sort of things could raise errors in your code. How are you going to have any idea what errors are going to be raised? This is always a challenge. When I was coding, this is something I always sort of got stumped on. Number one, you can test it yourself. And when you get an error, use that cyst.exeinfo function to get the name of the error. There is also, though, and there's a nice link here, a list of fairly standard Python errors. So this is a list of about 20 errors that you may want to catch, and it explains when they're raised. So that's something that's worth taking a look at after you're writing code to go say, oh, that actually could happen in my code. I should probably handle that error. So there is a fairly standard list you can use. The most important thing to do, though, is you have to test. That is really your best thing. First of all, so you get your code done, your first goal, your first test, is just see if everything works normally. Don't start by testing error handling. Just see if your code basically works. We actually have an expression for this. We call it the happy path. Make sure the happy path works. Right? Because it makes you happy. You're like, yay, my code works. Before you deal with all the error handlings and the weird what-if scenarios. Start with, can you just basically get the code to work? Does 10 divided by 2 work? Yes. Okay. Now that I've got that working, now let me try maybe entering incorrect values. That's a really common thing, because that's what's the likely scenario? User types in the wrong thing. So try typing in letters instead of numbers. Try 0. 0 does weird things.
And try the fringe cases. And this goes back to something that Susan really highlighted yesterday is, if you're doing a less than 1,000, test 1,000. Go in and test the fringe cases.
Yeah, exactly. Enter a value in the wrong format. Enter spaces. So try some things
that are... Try to break it.
Yeah, well, but not too hard. Try to enter things that you think a user might do. They might forget to enter a value at all and just hit the enter key. See what happens. So try sort of typical things you think a user might do. That's the second thing to test. Once you're handling that, then start going into what else could go wrong. Start using your brain. Go, what if the file wasn't there? So then you try things like, what if the file is missing? And then you get into, now just try anything you could think of that might break it. If you've got the time, try negative numbers. Try entering 99999999999.9999999 and just see what happens. But that's if you've got time. A lot of times, I'll be honest, we don't always get to that level of testing.
And not only that, I'd be remiss if I didn't at least mention it. And again, this is an advanced topic, but there is a concept called test-driven development where you actually write the tests before you write the code.
Yeah.
And one nice thing about that is when you start getting into that, you can automate a lot of that. Remember, Python, one of the biggest reasons that people use Python is for automation. Well, you could automate a lot of that. Just start feeding in random numbers and things like that to test it and go about it that way. So just just to mention it, put it out there, test-driven development and Python.
Yeah.
So
Yeah.
I'm done.
Yeah, absolutely. Which is basically the concept is you write a program that calls your program and passes it the values you would use to test it.
Exactly.
That's what it is really when it comes down to it. It's a program that calls a program.
Yep.
With the values you would use for testing.
Yep.
So that when you need to rerun, you make a change, you want to retest it, you want to make a change, you want to retest it, and you want to make a change and retest it.
Yeah.
You just call a program that calls your program with the right test values.
Yep.
That's the idea of automated testing. And when you get to more complicated code, that can be really powerful.
Yes.
All right, now the next question. Do you need to handle every single possible error that could ever occur anywhere in your code?
Absolutely.
No. What I would suggest is be practical about it. You can also write that generic error handler.
Yeah.
The one that says if something else happens, try except. Then you can say if an except happens but I didn't think of, here's how I want to handle it.
Yep.
I'll be honest with you, once you get further into code and you write more complicated, you will discover that the time it takes you to write the error handling for your code may be longer than the time it takes you to write the code.
Yep.
We often talk about 80-20 rules in a lot of scenarios.
Yeah.
There are times when writing the code that works for that happy path takes 20% of the time, and writing all the error handling code for every possible error handle situation of user enters the wrong format, user enters a 0, user enters a negative number. It takes 80% of the time.
Yeah, the way that I always approach it, what errors should I handle, is it's the ones that are important, that absolutely have that generic, and if you're going to do something different because of the fact that the file wasn't there or because of the fact that somebody gave you the number 0, then go ahead and focus on those parts. But if you're not going to do anything different, so if you give me a 0 and I'm just going to print a basic message, sorry, something went wrong. And if I can't find the file and I'm just going to print out a basic message, sorry, something went wrong. And if you gave me a bad string and I'm just going to, there's no reason in the world to keep writing all those different error handlers. Just put together that one generic one and be done with it. So there is no need to write special error handlers for every possible error.
No, you don't have to handle everyone specifically.
Yeah.
So it is okay to be a little generic in your error handling. In fact, I used to have a function that I called when an error occurred to look at the error that occurred, and based on that would display the appropriate message. So I had a function called error handler that accepted cyst.exe_info as a parameter, looked at the value and said, oh, if it's that error, do this. If it's that error, do this. That error, do this. And I just called the function.
Yep, there you go.
Now, how much error handling you also do does also depend on how the code's going to be used. If you are writing a system that's going to do air traffic control, I really, really, really hope you've got excellent error handling and you're handling everything, because I'm on an airplane on Saturday. If you're writing a fun little app that's going to tweet you when your plant needs water, I'll be honest, I'm not going to do a whole lot of error handling in that code, because, oh, what's the worst case scenario? Oh, the tweet doesn't go, and my plant, worst case scenario, my plant dies. Little different worst case scenario if my air traffic control system crashes.
Yeah, exactly.
So, got to be a little, so there is a bit of return on investment there. How much time to spend on it? How much does it, what will actually be the worst case scenario if your code crashes?
Exactly.
That should drive your decisions.
Yeah.
So your challenge for error handling,
Should you choose to accept it?
write some code that will open a file and read the contents. Allow the user to specify the file name. Which means there's a possibility that they'll type in a file name you can't locate, so you're going to need to write error handling to gracefully handle the possibility of a user entering a file name that you can't locate.
Exactly.
So now you guys can gracefully handle errors so your code doesn't crash.
Exactly.
Now what's freaking me out here, Christopher, is this is actually our last official module, but we do have a couple of things to talk about.
Yeah, we do have a couple of things to talk about. I actually, since I keep beating on that functions drum, I do want to hit that one last time. So I'm going to go back and close off one little thing. We saw a few questions about this, and since we talked an awful lot about methods or functions, it'd be worthwhile mentioning. Because one thing, just to be explicit about it, is inside of an except statement, could you take the error and just pass it over to a function? Absolutely, 100%.
So in my error handling, I could call a function and pass it the error message I got.
Exactly.
Okay, yep.
Yeah, absolutely,
All right.
100%. And that would be kind of very nice to be able to centralize. So if we come back to the code that I was doing earlier, you know, let's say that things like get names and print names, I want to be able to use that in a lot of different places. Well, what I could do is I could just take those. So all I'm doing is I'm taking code that we saw in the last module. Control X cut.
You took it out. How am I going to be able to call it?
That's a good question. I'm glad you asked that. So what I'm going to do is I'm going to go back to Solution Explorer, a real quick right click, and I'm going to say add, right there in front of me, new item.
Okay.
I'm going to say empty Python file, and I'm going to call this helpers. Now, one thing that I love to do is create just a bunch of helper functions. So I just
like
call them
my
helpers.
great formatter, date formatter that I love.
Exactly, yeah.
Okay.
So I just simply copied and pasted that code. So it's the exact same code. Now I want to be able to call that.
Yeah, because I still want to use those functions from the other program.
And the way that we're going to do that is just by simply saying import helpers. There we go.
That just makes too much sense because we've already been using import and cyst and all those great things.
We absolutely have been. Now let's go in and hit start, and you're going to notice it's going to fail on me. It's going to say get names is not defined.
Okay.
Because yes, I imported in helpers, but I still have to go one step further.
Okay.
I have to tell it that get names
is inside
inside of helpers.
Because, I mean, it can't go searching everything everywhere, so you have to give it a hint as to where helpers is.
Exactly. Yep. Yeah.
We saw that when we did that with cyst.exeinfo.
Yep.
When we were using the datetime functions and we imported datetime, we were doing datetime dot. So we've actually, that's exactly the same as when we're using the pre-provided modules.
That's exactly it.
So you can create your own modules.
You
wow.
can create your own modules just like that. That's simple.
I didn't think we'd get to creating our own modules in an introduction to programming. That's awesome.
But there it is. Awesome. And you've got one last little bit.
I got one little thing I want to show you.
Yep.
I will, but I want to show you something really cool.
Yeah.
A lot of you have been asking, what do I do when this course is over? What's my next steps? You know, some of you saying, hey, is there going to be a follow-up to this course? You know, and maybe there will be. We have talked about it.
There's been a lot of requests for that.
So
it's something we'd love
we
love
will
to
look
see.
into it.
Yeah, you know, this is not a guarantee of anything.
No, we'll look into it.
But yeah, we've loved how popular this has been. So yeah, this has been fantastic.
Yeah, so we're definitely going to look into that. But even if that happened, it wouldn't be for a little while. Even if it did happen, it'd be in a couple of months at least.
Exactly. We have day jobs.
Meanwhile, you need to practice to get these skills now and to get more comfortable with it. I've given you little challenges at the end of each module that we have provided. Now I've got a real doozy for you.
Okay.
And I may even give you a second one. I might add it to GitHub next week.
Okay.
Sonal, thank you very much for these. An intern that I work with was kind enough to create 2 bonus challenges for you. And these are going to require you to pull everything together. They're tough.
Yep.
So the first one, and I love this one's awesome. Many adults can't understand text message abbreviations. And your challenge is to write a program that will take a text message and translate it into words that your grandparents could understand.
Yep.
So if somebody types in, so funny, LOL, ROTFL, then that would be translated to, so funny, I'm laughing out loud, rolling on the floor laughing.
Yep.
So the way this works, you can assume that there is a file that contains one column, which is your text message abbreviations, and one column, which is the translation. So it'll say LOL, laughing out loud, ROTFL, rolling on the floor laughing.
Yep.
You have to write a program that will let a user type in the text message, and you return back to them the translated full message. This is going to take a lot of work. There's nested loops in here, string manipulations. Now, the nice thing is, I have got you hints. So if you go to the GitHub, download the PowerPoint, you're going to see all kinds of hints in here.
Don't worry about the fact that Susan's just kind of bouncing through that slide, because now I'm going to show you where to go get that.
Yes, so you have this. So when you're ready, when you've got some time, this is how you really try and put it together. And if you get stuck, you've got the solution. Go look at the solution, come back. And the nice thing is we've broken it into steps in the slides.
Yep.
And in the coded solution, it actually says this is step 1. Here's the code equivalent of step 1. Here's step 2 in the slides. Here's step 2 in the code. So we'll try to help you out, and you can follow that along. And even just learning how to read that code, you'll be amazed. If you can even understand that solution, you have learned a ton in the last 2 days.
Absolutely. Yeah, Absolutely.
Yeah.
And so if you're curious as to where to go get everything from here, I've got two little AKA MSs on here, and we'll put both of these into the chat window. But number one, this is the shortcut that you use to get to this course. This will be updated. A lot of people have asked, when is this going to be available on demand? Typically about 2 weeks. You'll get an email about it, but that link right there will always work. That will always get you to this course. So introprog-python. The second big one is all the codes and slides. We've thrown them onto GitHub. We've talked a fair amount about GitHub, but real quick, it's a great sharing place. A lot of open source projects use it. That's why we threw our stuff onto there. There's probably a little bit of cleanup work that we could do on some of the namings, which we'll go back and do. It's one of those things, doing live demos. Sometimes you kind of forget to be consistent there. It happens. So we'll do a little bit of cleanup, but the big thing that I want to point out on that GitHub is...
And on that GitHub, you'll see a button that says download zip file.
Yep, that's exactly
so
what I was going to go
link,
for. Yep.
Follow that link, and you'll see a button on that page that says download zip file. You click that button, and it literally gives you a zip file containing all our demos, all the challenges, all the slide decks, everything we've covered in the last 2 days to help you out.
It's right down here. So if you take a look at my screen, right down there at the lower right-hand corner, you'll notice download zip. And so all that you would have to do is just click on that, hit open or save. I'm just going to hit open, give it a couple of moments, and then poof,
You've
there
got
is everything that we've done.
Including, a summary of the challenges, solutions to the challenges, all kinds of great stuff.
That's absolutely it. All right.
And I think, my gosh, I think the only thing, we are done, but you're not.
Yeah, exactly. So a couple last little things.
And?
Yeah, a couple last little things. Yeah, you've got the challenges. You know where to go get all the source code. The last couple of things that I want to highlight. Number one, find us on Twitter.
Yeah, please.
Number two is down towards the bottom of the screen, you're going to notice the last poll question. That's the eval. Please take, the 2 seconds to go ahead and choose an item on there. And last but not least, Susan, I want to thank you.
It's been a pleasure, Christopher.
This has been an absolute blast.
Thanks, everybody.
A fantastic 2 days.
You've been an awesome audience.
To everybody out there. You guys have been wonderful. It's been great doing the Q&A here, and hopefully, everything allowing, we'll see everybody back here at some point. But until then, thanks again. Fill out the poll. Find us on Twitter, and go program Python.
Have fun.
Cheers.